I'm trying to share my screen, guys. Let me see. Why is kind of moving slow today? Can you see my screen? Am I sharing? Students?
No, sir. No, sir.
Oh, what's happening here? Sharing now?
Yes, sir. Yes.
All right, good. All right, just had a little bit of technical issue just now. All right, so it's obvious that you can hear me and you can also see the screen. So this is the paper that I gave you all to do, a number of questions on this paper. This is another revision session. You have to keep revising, all right? So that way we kind of keep the topics current. So we want to work through the questions on this paper, in the topics that we have done already. If you have not yet done the paper, you can do it after, even after I do it. If you did the paper, then any question you got wrong, you should go and redo it. And you can use this video to help because I'm recording this session. All right, so this is a January 2017 paper. Let's randomly pick this paper for no particular reason. All right, let's put it this way. The reason I picked this paper is that there's a circle measures question on it. All right, that's the reason I picked this paper today. And that's a topic that we just completed, circular measures. The next topic we're going on to is going to be plane and solid geometry. All right, so let's get into it. This is the actual exam paper. And this is number 1. It requires us to use a calculator or otherwise to calculate the exact value of this thing. And so what it is, because they say using a calculator and using full capacity, full capabilities of a calculator. So it's a matter of getting the calculator and putting that in the calculator exactly as it appears there. The device is really moving slow today, guys. It's moving slow today. I don't know why. The device is not cooperating today at all. Hold on, I don't know what's happening here. I'm trying to bring up the calculator. But the device is doing its own thing. Let's see. device is doing its own thing today, guys. So let me see. Let me start to share again. Oh my goodness. Device is acting up. I don't know what's wrong. Device is acting up, guys. It's moving extra slow today. It's just moving extra slow. Let me see if it is stable off. All right, let's try this again. I've never seen the device up like this before. All right, let's try this again. All right. So basically, I want to be using the calculator to work this out. All right, so I'm going to type this thing on the calculator right here, exactly as it appears. I always say that's why we need to get one of those textbook display calculators. So this is it. It's a fraction on the numerator we have a mixed number. That mixed number is 3.5. You can basically look up here what I'm typing. 3.5 times another mixed number, 1 2/3. And then I'm dividing that by another mixed number, 4 1/5. And the answer is 1.38888, which as a fraction, exact value, would be this value right here. 25/18. So because they said use a calculator, I'm just going to write 25/18 because after all, the calculator can work this out in one go. All right, that's the exact value. If you want to write this one as well, mixed number, it will be 1/7/18. Let's have a matter of ensuring that we actually put the correct in the calculator, the exact thing, which is what I have there. All right, and that finishes that first part. Let's move down to here. We have to calculate this one as well with the calculator. So let's go back. And this one is 5.47 minus the square root of a fraction. And the numerator is 0.1014. And we are dividing that to 1.5. And it's calculating. Oh, the calculator, the device is really slow today, guys. I've never seen this before. It says calculating. Man, The device is really slow today. It says calculated right here on this line. Something is wrong with the device. Maybe I need to reprogram it or something. I don't know. It says calculating. Oh my goodness. Let me try this. The device is slow. This is it. 5.21 is the answer. Exact value. All right, 5.21 is the exact value of that one. All right, what else? All right, so this one is a calculator again, so I'm still going to keep the calculator on the screen. But the device is failing me, guys, so I need to have it cleaned up or something. I don't know. All right, but this question says, table below shows the number of tickets sold for a bus tour. Some items in the table are missing. These are the missing items. So naturally, we're going to ask you for those three values. All right, so let's analyze the table. What it is that these are the categories of the tickets. These are the number of tickets that were sold. This is the cost per ticket. So in other words, one of this ticket is for this amount. One of the youth ticket is for $44.35. And so the total cost over here is obtained by multiplying. So multiply this times this to get this value. I will do the same on each line. This times this equals that value. This times this equals that value. That's the relationship. All right. So I want the value of P. To get the value of P, we're going to work on the first line right here. That 5 times P is equal to 130.50. So that's 5 times P is equal to 130.50. I'm not going to put the dollar sign because the dollar sign is in the table right here. So P is just a value, just as though this is just a value. I don't need to put the dollar sign on it. So from here to find P, I just need to divide by the 5. And so the P is going to be 130.50 divided by 5. I'm going to do that calculation. 130.50 divided by 5. That's 26.1. And because it's money, you have to put 26.10. So P is 26.10. That's the value of P. And that the cost of a juvenile ticket is $26.10. What I go to that? Let's make it, let me just do this picture. What okay? Can you hear me? Can see the screen? But is there?
Yes, sir. Yes, sir.
All right. Next part wants the value of Q. Next part wants the value of Q, which is obtained by on this line. So it is 14 times this value that is equal to Q. All right, so let's do that. It's 14 times 44.35. That is equal to the Q. Do this calculation, I will have Q. And so we can say the Q becomes equal to whatever this becomes. So it's 14 times 44.35. That's 620.9. But remember, Q again is money. They'll put 620.90 because Q is money. All right, let's continue. Down here, it says an adult ticket is twice the cost of a youth ticket. So the adult ticket, right, is twice, means 2 times the cost of a youth ticket. Now, what's the cost of a youth ticket? Youth tickets is here. Youth ticket is $44.35. And this adult ticket is 2 times that at $88.70. That's 2 times 44.35, which becomes 88.70. All right, so This is 88.70. I'm going to put it on the table. 88.70. Let's say multiply this one by 2. That's what they said. Use a different color for that. All right, so multiply this one by 2 to get the adult ticket. All right, and so now it is R times this value that is equal to that one. And that's how I want to find the R. Let's put it right here and copy it down. So R times 88.70, that is equal to this figure of 2483.60. This is the calculation. Let's copy it down. Everything is so to the rest of it. So let's see. And so to find the R, we need to divide by this figure. Divide it on here. So the R becomes 2483.60 divided by 88.70. That will give us the value of R. So that is 2483.60 divided by 88.7. That's 28. So I equals 28. I'm not putting any point anything on that because that is just a number of tickets. R is the number of tickets. All right, so that's what we have. Down here now, it says the bus company pays 15% tax, pays taxes of 15% on each ticket sold. Calculate the tax paid on by the bus company. So basically, you're paying 15% on the total. I paid on each ticket, so you want to pay the 15% on the total. So we need to know what the total is. All right, so let's go back up here. And the figure that is missing is this Q figure in the totals column right here. I'm just going to put that in there, 1620, and then get the total. So this figure is supposed to be 1620. 1620, let's see. 620.90. 620.90. This is 620.90. Then we can get a total on this line. To get what the total amount collected was. So when I add these three figures now to get the total, it's going to be 130.5 plus 620.9 plus 2483.6. That's 3235.00. That's the money. So calculating tax on this amount. So the tax then equals 15% times this figure. 15% times that figure, which is, let's put the dollar sign on it, 3235. And work that out, and we get the tax. So it's 15% or 0.15 times 3235. The tax is 485.25. So this is the calculation we need on the next page. Let's just copy this down. Right here. This is it. Let's take this blue part out. That is the tax. All right, better go to that.
Yes, sir.
All right. Let's go on to the next question. This one wants us to, I don't think I need the calculator now. So let me close out that one. See if we move a little bit faster. All right. So this one wants us to write this as a single fraction. right side of thing a fraction, we want the two denominators to be the same. So I'm going to multiply this, two denominators to become 12, and 12 is the lowest common multiplier of the 3 and the 4. So I'm going to multiply this denominator up here and down here, and multiply this denominator up here and down there. Right? So basically, I'm multiplying this fraction by 4 over 4. I'm multiplying this fraction by 3 over 3. All right, so then it becomes equal to 4 times this numerator. So it's 4 times the 2x is 8x plus 4 times this 3 is 12 over this 4 times 3 is 12. You're adding 3 times this numerator, which is 3 times x, which is 3x, and 3 times -4 is -12. You're dividing that by the 4 times 3 here, which is also 12. Now, because these are now with the same denominator, they are related. And so the answer is going to have that same denominator. And then we can just add the like terms on the numerator. So it's 8x plus 3x at 11x. And then 12 and the -12 eliminates the 12. All right. And so basically this is the answer right here. That is it. All right. This is why this thing moving slow, because it's updating in the background. I need to remove that connection. All right. So far so good. I'm gonna get the blue ink instead. So far so good, guys.
Sir.
All right. Down here it says write the following statement as an algebraic expression. So basically interpreting this statement and put it as an algebraic expression. It says the sum, meaning you're adding, of a number and its multiplicative inverse is means equal 5 times the number. Let's set it up. The sum means that you're adding a number. Let's call that number n, or we can call it x. And it's a sum of one. So we're going to be adding the multiplicative inverse of n is 1 over n. That's the inverse. The multiplicative inverse is 1 over n. Is means equal. 5 times the number means 5n. So this is the statement right here. That is it. But okay with that? Let me write this 1 over n a little better. 1 over n. So this is the expression for that statement. That is it. The sum of a number and its multiplicative inverse, that's it. Is means equal 5 times the same number. 5 times the same number. Now this n could have been x or y, any letter you want to use. I use n to represent number. If you want to use x or any other variable, another letter to represent that unknown number, you could use it. And you get the marks just the same. All right, next one. This one wants us to factorize. Now this clearly is the difference of 2 perfect squares. So it can be written as x squared minus 6 squared. And the difference of 2 squares is the difference of the two numbers, x minus 6, times the sum of the two numbers, x plus 6. Easy like that. That is it. All right. Then down here, we want to factorize this. That's a normal trinomial, the quadratic 3 terms. And so we're going to use the method of splitting this middle term. So how we would do it is that we are searching where we multiply these two n coefficients first, which is 2 times -12, which would be equal to -24. They want factors of this -24 that add to the middle coefficient of a +5. That's what you want. Factors of -24 that add the +5, and you're going to split the middle term into those factors so you can factorize by parts. If you cannot see with two factors of 24, -24 will add to +5. you can go down list of factors. Remember, since the product must be negative, the larger of the two factors that you're using also must be positive, must be negative. No, the larger one must be positive because you want the sum to be positive. But one factor of this will be positive and one will be negative. Let me say that again. Since the sum of the factors of negative 24 must be positive, I give the larger factor the positive sign. And remember, the sum of the factors of a negative number is such that one will be positive and one will be negative. All right, and if you can't see that it's 3 and 8, you can go down the list of factors and try them. So you can maybe try 1, and 24. Give the larger one the same sign as this, which is the plus, and this one minus. But when you add these, you're getting 23. You don't want 23, you want 5. So no, you don't want that. Then the next two factors of 24 will be 2 and what? 2 and 12. With the larger one positive and the smaller one negative. But 12 minus 2 is 10. So no, you don't want 10. You're trying to get 5. So next two factors of 24 with 3 and 8. The larger one positive and the smaller one negative. And then the 8 and minus 3 give you this 5, which is a positive 5. So yes, you're going to split this 5x using these two coefficients. All right, so it's going to be negative 3x and 8x, or you can put 8x minus 3x. All right, so it means then that this expression is going to become, let's go back for the blue, 2x squared remains the same. You're splitting this 5x using these. I'm going to put 8x from this one minus 3x from this one. If you want, you could have put minus 3x plus 8x just the same. Doesn't matter. But the reason why I put the 8x first, because it factorizes nicely with this 2x squared. And this minus 3x factorizes nicely with this negative 12 that comes back here. You're going to factorize the first two with the highest common factor. Highest common factor in these first two terms is 2x. Out of this, if you factorize out 2x, you're going to get x. Factorize 2x out of this, you're going to get plus 4. Now, this thing that is in the bracket, the same thing must appear in the bracket over here when you factorize these two terms. So I always say write it back first, x plus 4. Then in between here has to be plus or minus some value. It has to be the factors of these that will give you the x plus 4 in here. So all you can do it, you can divide this minus 3x by this x to know what the factor in between here is, a negative 3. Or you can divide this negative 12 by this positive 4, divide it to know that in between here is a negative 3. So anyway you want to look at it, this is negative 3 inside here. Because if you expand the negative 3 back here, you're getting back these two terms. All right. Then now, this x plus 4 is a common factor, and they're added with this 2x and minus 3. So the 2x minus 3 becomes one factor, 2x minus 3, and multiply that by the common factor of x plus 4. So these are your two factors. Now, if you write it as x plus 4 in front times 2x minus 3, that is still correct. So either one is good. All right, so that is it. But okay with that?
Yes, sir.
All right, let's move on. Here now it gives us this formula for the volume of a cylinder. I want us to transpose to make R the subject. Let's look at it. So it's V volume equals pi R squared times H. You want to leave R by itself as a subject. What I normally say is that you transpose everything away from the R. First, you're going to move the pi and the H. Over here, they are multiplying. You need to divide them onto this side. All right? So I'm going to first get that b over pi times h equals r squared. Then to get rid of that square, you have to square root both sides. But the inverse of square is the square root. And when you square root both sides, the square root wipes away that square. Right? And so the result is that this is left with an r by itself will be the square root of b over pi h. But since I make it the subject, they like to put the subject on the left side. So I'm going to write my final line with the r on the left side. R equals this expression, square root of b over pi h. This is my answer right here. Are you okay with that?
Yes, sir.
Beautiful. Moving right along. Next part says they're telling us that this thing is equal to that. In other words, when we complete the square of this, it becomes equal to that. We have to tell them the value for a and b. Now, because this one is numerical, I think the easier way to do this is to expand this. And after we expand it, to compare the coefficient with this one, right? Because it's easier to expand this because it is numerical. So I would expand that first. So okay, let's expand this. Want to expand the perfect square here first. Let me expand a perfect square. So it is that the x squared plus ax plus b would be the same as. I'm going to expand this first and then minus the 3. We expand a perfect square. Remember, it's the first term squared, which is x squared. Then it's twice the product of the two things, meaning you multiply the x times the 2, which is 2x, and then you double it. You double the 2x. The 4x, the middle term is 4x. So you multiply them first, and then you double the result to get the middle term. And then now you square the 2. And when you square the 2, you're going to get 4. Then this minus 3 has to come back here. Minus 3. So remember, when you expand this perfect square, you're going to get these 3 terms. First term squared, twice the product of the 2. The middle term here is twice the product of the 2, meaning you multiply the 2 terms in there and double the result. And then the third term is the second value in the bracket squared. All right, that's what it is. And if we consolidate, we get x squared plus 4x. This 4 minus 3 is 1. And that is the x squared plus ax plus b. And so if you compare coefficients, then this a is equal to 4, and this b is equal to 1. So we can write that. A equals 4, b equals 1. And these are our answers. All right. Could have gone the other way, you know. We will complete the square of this with the expression, but we have far more work. Far more work. I think this is the easier way to do it. But are you okay with that?
Yes, sir.
All right. Let's continue. Then I say we have to skip number 3. I don't do the set. Skip number 3. Going on to number 4, which is the functions question. All right, so this functions question now gives us f of x equals that, and g of x equals that. I want us to find g of 0 plus g of 5. So it means that we're substituting the 0 in the g function, and we're also substituting 5 in the g function. We're adding them. So this then becomes equal to the g of 0 first. It will put 0 here. So it becomes 3 times 0 plus 1 over 2 plus g of 5 now is we'll plug 5 in there. It becomes 3 times 5 plus 1 over 2. So these two fractions are already related. Both of them have 2 on the denominator. This numerator is going to be 1. Let's look at it. 1 over 2, because this 3 times 0 is 0. Plus this diameter is going to become, this numerator is going to become 16. 3, 5, 15 plus 1 is 16. 16 over 2. The diameters are the same. So just add the numerator values and put a common denominator. 17 over 2 is the answer for that one. All right, guys. All right, let's move on. Then we want f of g of 5. Now let's look again. We just did the g of 5. You know? The g of 5 is what we calculated here, which worked out to be this value. Okay, this value is actually 8. So the g of 5 is 8. So we have to work it out again. Because this means f of g of 5. And from here, the g of 5 is 8, as I just said. 16 over 2 is 8. So we really want to be working out f of 8, because the g of 5 part, we know from the first part of the question that is 8. 16 over 2 is 8, g of 5. But understand that so far?
Yes, sir.
We're working on f of 8. So f of 8 means now that we want to plug 8 into the f function right there. So it becomes 4 times 8 minus 7. Now 4 times 8 is what? 32. 32 minus 7 is what? 35. Is this 35? It's correct? No, not 35. 25. 25. My mistake. 25. That's correct. 25 and 7 is 32. But okay with that?
Yes, sir.
All right, beautiful. Let's continue. You know what? F to the minus 1 of 1. All right? F to the minus 1 of 1. Now, we can do this 2 ways. Let's try what f of x is. Remember, f of x is 4x minus 7. Let's make sure. 4x minus 7 is. All right? Now, this f to the minus 1 of 1 can be found by finding f to the minus 1 of x first. Then we do the f to the minus 1 of the 1. Can do it this way. This is the way that most persons would do it. But I'm going to do it another way for you today. This is f of x. I'm going to say from this function, let's do it this other way. I'm going to say let f to the minus 1 of 1 be equal to some number n. So whenever you calculate the value of n, you have found f to the minus 1 of 1. Now, if f to the minus 1 of 1 is equal to n, then it means that the number 1 is equal to f of n. I can take the inverse of the f to the minus 1 and put it on that side. And the f of x is this. So if f of x is this, then f of n means I'm substituting n in here. So it means that 1 is equal to 4n minus 7. So you see, anyway, you take it, you have to do some form of transposition. To get f to the minus 1 of x, you would have to transpose this. It's the same thing. To get n out of this expression, you basically need to transpose to make n the subject. So what I'm going to do is transpose the 7 and then divide the 4. And so the n is going to be 1 plus 7. That's when I bring over the 7, it becomes plus 7. And this 4 that's beside the n, I divide it under here. Divided by 4. Now this works out to be 2, because this is 8 divided by 4 is 2. So the n is equal to 2, which basically means, i.e., f to the minus 1 of 1 is equal to 2. That's a nice little neat way to do it without directly finding the f to the minus 1 of x first. We had to do some transposition. Same transposition you would have to do to find f to the minus 1 of x is the same transposition we have to do right here to go from this line to this line. So Anyway, take it off a transpose. All right, so that's a nice thing to do it. All right, let's move on. The next part gives us these 2 points, and it represents a line segment. It says determine the gradient. The gradient, the difference in y over difference in x. Let's write it like this. Gradient of PQ equals rise over run rise a difference in x, difference in y, sorry, difference in y over difference in x between these 2 points. The thing is, the direction we go for the difference in y must go the same direction for the difference in x. So let's say we're using this point minus that point. The difference in y will be this y value minus this y value. All right, so it will be 7 minus, no, this y value is negative 1, divided by this x value minus this x value, to minus 6. So this is up, becomes an 8, because this minus is a plus, so it becomes an 8. And this is 2 minus 6, which is negative 4. So 8 divided by negative 4 is negative 2. So the answer here is negative 2. So the gradient of PQ is negative 2. Negative 2 is the gradient of PQ. All right, moving along. Next part says the coordinates of the midpoint of PQ. Let's write them down. So remember, the midpoint is like an average point. So P is 6, negative 1, and Q is 2, 7. All right, let's move this down. This them here. So the midpoint of PQ, let's call it M. It's the average of the x values. And write it out here. Midpoint is the average of the x. Let's call the midpoint M. Is the average of the x values and the average of the y values. That's how you get the midpoint, quick and fast. So M is the average of these 2 x values, which is 6 plus 2 over 2, and the average of these 2 y values, which is negative 1 plus 7 over 2. That works out that M is the point, because this is 6 plus 2 is 8, 8 divided by 2 is 4, and then this is 7 minus 1 is 6, 6 divided by 2 is 3. So the midpoint is right here, 4, 3. All right. Next part says you have to find the equation of the perpendicular bisector of PQ. Let me do a schematic for you to see. So 6, negative 1, 2, 7. So it's like you have the line like this. All right. So this is where Q is. And this is where P is. This question is asking for the perpendicular bisector, which is the line that passes through the midpoint M and is perpendicular to it. So the question is asking for this second line, which we call it line 2, perpendicular bisector. It passes through the midpoint M and is perpendicular to PQ. Now, to find the equation of this line 2, we need to know 2 things about it. We need a gradient and a point. We have the point already. Point is 4, 3. We need a gradient. Now, the gradient of PQ, or gradient of the perpendicular bisector, which is called M2, becomes equal to minus 1 over the gradient of the first line, the PQ line, because they are perpendicular. So like we're taking this gradient of 2, remember this line gradient was negative 2 right here. I'm putting it on here. So it becomes negative 1 over negative 2, which becomes a half. Or we could have simply taken this negative 2, right? That negative 2 over 1, flip it and change the sign. It will become 1 over 2. Right? So anyway, take it, the perpendicular gradient is 1 over 2. So we're using this gradient and this point now to find the equation of the line. And the equation of that second line using what we call the BFF formula is y minus y value at m equals the gradient of line 2 find equation of line 2. So we use the gradient of line 2 into x minus xm. So this xm, ym and xm represent the coordinates of the point, which is here. And this is the gradient that we just found here. Let's set it up. It becomes y minus ym. Ym is 3 equals the gradient of that second now is a half into x minus x value at point is 4. Since this half of 4 is a whole number, I must multiply this out and put y minus 3 equals half times x is half x. And half times this negative 4 is negative 2. And this 3 comes over, becomes a positive 3. So it becomes 3 minus 2 is 1. So the equation becomes y equals half x plus 1. This is the answer right here. But okay with that?
Yes, sir.
All right. Let's continue. All right. I think I told you to skip this part. That is something I want to be doing next. We don't do this yet. Similar triangles. We'll do that in the next class. But I gave you this question to do. It's that transformation. All right. So it says the graph below shows triangle DEF and D prime, E prime, F prime after a transformation. So this is the image I, this is the object. All right. Now they're going to want us to describe it. All right. So might as well just figure out what transformation it is from now on. So there has been a 90-degree turn. How I know is that this DE line, I'm using a reading. This DE line was horizontal, pointing this way, and DE is now vertical on the image, pointing that way. So you know that there's a turn in this direction. All right, so that's a 90-degree, because from horizontal to vertical is 90 degrees. So that's 90 degrees anti-clockwise turn right now. The question is, where is the center of that turn, of that rotation? It's a rotation. Center of rotation usually is the origin. So I like to always check if the origin is the correct center of the rotation first. I can check it by rotating the coordinates of the points 90 degrees to see if we get back the image point. So for example, this point will be 4 units this way and 2 units up. If I rotate this L-looking thing 90 degrees that way, then this side will go 4 units up on the y-axis. This piece at the head of it will form horizontal like this. So it takes it from E to E prime. So that is correct. And we can prove that to be true with another point that we're good to go. So let's do it with D. So D is 1 unit from the origin, 1 unit and 2 units up. So I'll take this 1 by 2 and rotate it again 90 degrees that way. So this horizontal piece that's on the x-axis is going to go on the y-axis. And this 2 units piece on the head of it is going to go 2 units this way, which takes to the D prime. So it means that this L-looking thing was rotated 90 degrees to get this. So we can confirm that the center of the rotation is the origin. So therefore, I have an anti-clockwise 90 degrees rotation about the origin. I should know the matrix for that is this one. -1 up here, 1 down here, 0, 0. Anti-clockwise 90-degree rotation about the origin. That's the matrix, if they wanted it. But let's answer the questions. Now we figure that out. Let's answer the questions. First part wants us to write the coordinates of E. Let me get the blue in. So the E is this point right here. Based on this point, this is 1, 2, 3, 4 units by 2, 4, 2. So that's the point 4, 2. All right. Next part says describe fully transformation by DE, F onto D prime, E prime, F prime. So it's an anti-clockwise 90-degree rotation about the origin. So it's an anti-clockwise 90 degrees rotation about the origin. Remember also that an anticlockwise 90 degree rotation is positive rotation. We'll put a positive 90 degrees rotation. This would mean anticlockwise. Positive rotation is anticlockwise rotation. And note in this description, I've given 3 components of rotation. I've given the, well, 4 things. I have to give the name, and the rotation has 3 components: angle, direction, and the center. If you leave off any one of those, you're going to lose the marks. The thing that people leave off the most is to say that it is about the origin. Try getting into the habit of always ensuring that you stay at the center of a rotation. But that is the description right there. See, 3 marks for it. 1 for each component, basically. All right, next part says, on the grid, we have to draw D double prime, E double prime, F double prime, the reflection of the prime triangle in the x-axis. Instead of saying x-axis, they could have instead said the line y equals 0. I've seen that in questions before. Instead of just saying x-axis, they say the line y equals 0. X-axis is y equals 0. In any case, we're affecting the prime triangle in the x-axis, this one. So this is the x-axis that we're affecting in this one. That's the x-axis. All right, and do your reflection 1 point at a time. Image distance equals object distance. So for example, D is 1 unit to the mirror lines coming 1 unit on the other side. Let's use the blue for this. Just coming to here. That's D double prime. F, same thing. 1 unit to mirror line, 1 unit on the other side. Just coming here. F double prime. Then E. E is 1, 2, 3, 4 units to the mirror line. It's going to go 1, 2, 3, 4 units on the other side out to -4. So it's coming over here. That's E double prime. I know that 3 points are in place. You simply draw the triangle, join the points with straight lines. Use the ruler and draw that triangle. That's it. All right, nice and easy. That's it. That finishes that question. Did I tell you to the number 6? I don't remember. I think I told you to the number 6. Did I tell you to the number 6? The map and scale question. I would have told you to the number 6 because it's something I've done already. Yes. I did say the number 6. All right, let's go. All right, so this one gives us the scale of a map is 1 to 25,000. It means, for example, that 1 centimeter on the map is equivalent on the land to 25,000 centimeters. That's what the scale means. Unit, very important. Oftentimes, when you're working on the land, you have to bring this side to meters or to kilometers. All right, so you know what 1 centimeter on a map is on the land in meters or in kilometers, but that's where you start. Anyway, it says Adelaide and Jersey are 31.8 centimeters apart, determined in kilometers. Say I want it in kilometers, the actual distance. So it means that I need to convert this scale to kilometers. So let me do that down here. Let's do it on the side. Convert the scale to kilometers. All right, because the map will always be in centimeters, you know. But the land, you measure the land in either meters or kilometers. So to go from this to meters, first you divide by 100. You're changing this to meters. 100 centimeters make a meter. So it's 1 centimeter on the map. Divided by 100, you get 250. 250 meters. Then to get from meters to kilometers, you divide by 1,000. But 1,000 meters make a meter. So 1 centimeter on the map is divided by 1,000 is 0.25. is 0.25 kilometers. So that becomes a scale for distance, right? This is a distance scale that they give you all the time. So based on that now, this distance is obtained by simply multiplying this ratio by this amount. All right. So we have to do this and multiply by that amount times 31.8. So all we have to do. And then this side on the map is going to be it's going to be 31.8. You don't know that amount here? Huh? You don't know that amount here? Centimeters, and that goes to multiply this now by 31.8. Let's see what that becomes. I'm just going to do that on my phone right here. So it's 0.25 times 31.8. That's 7.95 kilometers. So this is your answer right here that we're looking for. 31.8 centimeters on a map is this amount of kilometers on the land. But okay with that? But okay with that? Hello? All right, let's continue. Nobody's answering. Let me continue. Then it
Yeah, I
says,
did answer.
okay, all right, good. It says the actual distance in these two towns is 2.7 kilometers. How many units apart are they on the map? I'll give you units in centimeters. So now we're working from this scale. I want the land side to become 2.75. That's all that it is. Let's go back to the scale. All right. So we have map for land. It's 1 to 0.25 kilometers, centimeters. I want to know what 2.75 is. So I want this side to become 2.75. So we can basically take this and multiply it up until we reach 2.75. And that's one way to do it. So for this to become 1, we can multiply by 4 first. All right? We can multiply it by 4 first, or divide to 0.25. Anyway, we want to look at it. Let's multiply by 4 first. So this becomes 1. We're going to take it up to 1 and then take it up to 2.75. So it's going to become 4 centimeters to 1 kilometer. All right? 4 centimeters to 1 kilometer. And you really want to know 2.7 kilometers. So you're going to know multiply by 2.7 times 2.75, 2.75. So multiply this now by 2.75. I multiply this by 2.75. So this part is going to become 2.75 kilometers. Multiply this by the 2.75, and you know what the answer is. So it's going to be 4 times 2.75. That's 11 centimeters. And this now is your answer for the second part. 2.75 kilometers is this 11 centimeters on the map. That is it. All right, that finishes that part. So let's do this scale. Let's talk about the ratio. Let's multiply and divide by values to get the information that you want. As simple as that. Let's continue. So this question looks like a circular measures question. It's a circular measures question, but not working in the sector. But then forming an angle, for example, from the center there. But the circular measures formula that we use are with angles from the center. All right, sector angles. All right. That's what this one says. The diagram below shows a square ABCD drawn inside a circle. So this is a square drawn inside a circle. So the vertical square line of circumference It says the length of a side of a square is 11 centimeters. So this is 11. This is 11. This is 11. And this is also 11. And I thought we need to draw two of them. Now, remember, this is a square. So the angle right here is at 90 degrees. Angle subtended by 90 degrees is a diameter. A diameter subtends 90 degrees. So this line is a diameter. AC is a diameter. All right? AC is a diameter. And this now is a right angle triangle as well. And this is a 90. And that's the hypotenuse, the diameter. Question says, show that the diameter is 11 square root of 2 centimeters. So we're going to use Pythagoras' theorem inside here to get the diameter, AC. The diameter is AC. So I want to tell the examiner that the diameter in the diagram is actually AC. So when you calculate AC, you'd have found the diameter. Pythagoras' theorem inside here tells us that AC would be the square root of 11 squared plus 11 squared. That's what it becomes. This becomes AC is the square root. This is now 2 times 11 squared. 2 times 11 squared. Now this now becomes square root of a 2 times the square root of the 11 squared. Square root of 2 times the square root of 11 squared. Well, the square root of 11 squared is 11. So then this becomes square root of 2 times 11, which is same as 11 square root of 2. Same as 11 root 2 centimeters. And that is shown. Let's use Pythagoras' theorem. That is it. But after that,
Yes, sir.
all right, good. Next part now says, write your answer correct to 2 decimal places. The area of the circle. All right, so the diameter is this. So the radius is half of that. All right, so since the diameter is that, the radius. We know what circle measures with the radius. The radius R equals 11 root 2 over 2, half of it. So this is the radius that we're working with. I'm going to work with the square on it, with the root on it. We're not going to put this as a decimal. You're going to give the answer to 2 decimal places. We can still work with this for the time being. So I want the area of the circle, which is pi r squared. So it becomes pi times 11 root 2 over 2 squared. So it's a 2 decimal places. You can put this in a calculator. Let's see what we get. I'm going to use the actual pi on the calculator because they did not tell us any estimate to use for pi. When they don't, use the pi that's on your calculator. So let me get the calculator so we can see the work. All right, let's see it here now. We're doing this one. I'm just going to put it in there exactly as it appears there. Keep it simple. So it's going to be pi, sigma pi, times bracket, fraction, 11 square root of 2 over 2, close bracket, square that. That's 190. It says 2 decimal place, so it's 190.07 if you correct it to 2 decimal places. And that is centimeters squared. That's the answer. But I got it that?
Yes, sir.
All right, next part wants the area of the square. Remember, each side of the square is 11 and now. Each side of the square is 11. So the square, area of the square is just 11 times 11, which is 121, right? So the area of the square is equal to 11 times 11, which is 121 centimeters squared. The next part now says the area shaded. All right, let's figure this out now. So the area shaded so let's look what we have. Take this off. We have the area of the entire circle. And we have the area of the square. So the sum of these four regions, here, here, shall be the segments. The four of them becomes the area of the circle minus the area of the square. That's the area shaded in total. But the question we really just want one of them here. So to get this one of them, we need to divide this by 4. Because it's 4 of them, I want to want one of the 4. So divide it by 4. So this will give you the area shaded. But understand that? But
Yes, sir.
Good. So the area of the circle minus the area of the square divided by 4. Good. All right. So it becomes equal to, let me put it in red. Becomes equal to area of the circle minus area of the square. That gives you those 4 segments, but you want one of them. So you divide that by 4. So it's 190.07, 190.07 minus this 121 square. And divide that by 4. Do this calculation, whatever we get is the answer. So fraction 190 minus 190.07. 190.07 minus 121 and divided that by 4. And I said 2 decimal places would be 17.27 centimeters squared. That's the answer. Right. Better go to that.
Yes, sir.
Remember, any question I didn't get, you understand before, we go and work it over again. More math equals better maths. All right, so that was number 6. Number 7 is that topic we're going to be doing soon, to statistics. Skipping over that. Then we're also going to be doing pattern questions soon as well. We're skipping over that. We have done those in class as yet. We can do this one. This one is a the variations question, part A. It says, the table below shows pairs of values of x and y where y varies inversely as x. Y varies inversely as x. All right, inversely means 1 over 1. So it's y equals k over x, inversely as x. First variable equals k over the second variable. I don't want us to write it here. So writing this right here. That's it. Y equals k over x. And we look at it, we take the x and multiply it up here, k is equal to x times y. Right? So it means that a constant is always equal to the product of the x and the y. All right, so using both of them. All right, so if we want to find a constant, we just need to multiply the x and the y. And we have a pair of values here that we can use to find the k. We also have a pair of values here that we can use to find the k. And you realize that when you multiply the 3 times 2, you get 6. And when you multiply the 4 times 1.5, you're still getting 6. So the k is 6. Then we take it, the k is the product of x and y. So it's a calculate the value of k. So the k is equal to xy. So the k is equal to 3 times 2, which is 6. Or you could use the other known pair. The k is equal to 4 times 1.5. K is equal to 6. So it means that the product of these values, this product will be 6, and this product will be 6. The product is always 6. That's what it means. All right? So down here, it says to find the value of A and B. No problem. The product is always 6. All right? XY will always be 6. All right? This formula governs everything going forward.
5 people.
With a mic, please. X5 will be 6. So this pair, the 8 times 1.5 is 6. 8 times 1.2, sorry, is equal to 6. So divide by the 1.2. So the A is equal to 6 over 1.2. That looks like 60 over 5. 60 over 12, which is 5. So the A equals 5. And the B is that the 20 times B is equal to 6. 20 times B is equal to 6. Because the XY is always equal to 6. So the B is equal to 6 over 20. The B is equal to 3 over 10. So the B is equal to 0.3. And that is, those are your answers. Nice and easy, quick and fast. But are you okay with that?
Yes, sir.
All right. Next part here is a quadratic. All right, let's do this one. And it gives us the values for x from 0 to 6. In other words, it's only giving us the part of the graph from x equals 0 or to x equals 6. All right, it's clear as my cheap quadratic. Sorry, the y-axis intercept is 8, as you can see, matching that 8. This is the minimum point right here. These are your two roots where cross the x-axis. Usually when you have the graph, everything becomes easy. You have to be calculating everything. Everything is on the graph. All right, the question says, use the graph. See, use the graph to solve this equation. This equation gives you the roots. I'm going to tell the examiner how I use the graph. Let's say use the graph, you know. So this equation gives the roots. So I'm going to say give roots. And roots are these x values where the graph intersect the x-axis. So it's x equals 2 here and x equals 4 here. Nice and easy. All right, I'm telling him that these are the roots. I'm going to say root. But the question says use the graph. So this is my showing how I use the graph. Now when you solve the equation, you're getting the roots. When you solve the equation related to the function graph, you're finding the roots. All right, so this equation gives you the roots. All right, next part says write down the coordinates of the minimum point. The minimum point is here. So I'm going to do it again and say this is my minimum point, which is 3, -1. 3, -1. I'm going to put the word min here. So you can know that that's how I get my minimum point from the graph. I just said use the graph. So I'm going to write my minimum point is 3, -1. All right. Next part says write this in this form. No, because I have the graph and I have all the values, I do have to actually do this calculation now. Now remember, the minimum point, which is 3, -1, is really my xt and my yt. It's my xt and my yt. So my xt is 3, yt is -1. When I write this in this form, so I'm using the a, h, and the k, I can write this as a into x minus xt squared plus yt. Now the a is clearly 1 because the coefficient of x squared is 1. So it becomes equal to 1 bracket x minus xt is 3 squared and yt is -1. So I'm going to put -1 and that is it. Done. You can fast. I don't need to go and actually do the process because I have the graph, information is there. But this form, which is the vertex form, it relates to this turning point. And so once you have the values at that turning point, you can plug them in this vertex form. And you're done. This one don't need any calculation. All right, but I understand that? Very good?
Yes, sir.
Beautiful. I'll do the mathematics the easy way, all right? Next one says, on the same axis, draw the graph of this line. And it's just like the graph of y equals x minus 2. Just like I call it g of x, don't matter. There's a line that crosses the y-axis at -2 and has a gradient of 1. But the y-axis, the coefficient of the x there is 1. All right, so that's all I need. So we're going to draw that line. So let's draw it in purple. So cross the y-axis at -2, we said, right? -2. Yeah, -2 into a gradient of 1. -2. Right. Cross the y-axis at -2 right here. As a gradient of 1, right? So the gradient equals 1. Now 1 is the same as 1 over 1, which can, for example, be 2 over 2, still 1. So when I rise 2, run 2. And it's units, right? So from here to here is 2 units, not two grids, you know, it's 2 units or 1. So it's 2 units. This is the 2 units run will take us out to 2. So not 2 grid, is 2 units. So if you rise 2 for this and run 2, you come into here. So it means that this is a point on that line. And if you rise 2 again, 2 units, not 2 grids, 2 units is a rise to here. 2 units from 2 to 4 coming across to here. So that's a point on the graph as well. I'm doing it the easy way, guys. Then from here, I'm going to rise 2, run 2 again. So rise 2 units from 2 to 4, not 2 grids, you're riding 2 units. And from 4, if you run 2, you're going to end up at 6. So you're running over to 6 over to here. That's another point on the graph. So you rise 2 units, run 2 units, not 2 grid. You're not running the grid. So basically that's your GFX line through these points. So you're joining these points with a straight line now. Straight line through those points. So you're gonna like that. Use your ruler and draw it. Don't draw it friendly like me. That's your GFX graph. All right. All right. And then I'm sure they're gonna ask us about these 2 points of intersection. This one and this one. I'm sure they're gonna ask about those 2 points without a doubt. That's how these questions are. The more questions you do, the more you know and learn what they ask you. They're gonna ask you something for those 2 points. That's the graph. All right, so I've done the graph. Then now it says, sit here, it says hence solve the equation. So this is where the graph and the line intersect. This is where g of x, no, not g of x, f of x. The graph was f of x, right? So the graph f of x, did they call it f of x? Did they call it f of x? They call it f of x. So the curve is f of x and the line is g of x. So this is where f of x equals g of x. Now know that this is an equation in x alone. So the solution for that equation will only be x values. So you're really trying to find the x values where the 2 graphs intersect, which are at those 2 points, right? These 2 points that I've circled in green right here. These 2 points, this one and this one. That's where f of x equals g of x. Same thing here. F of x equals g of x. X value at this one is 2, just x equals 2. X value at this one is a 5. I'm going to put x equals 5. So those are my 2 x values, 2 and 5. Let's try that. X equals 2, x equals 5. So my answer for this is x equals 2, x equals 5. Well, can we check it, you know? Can actually plug the 2 in there and see what we get. So I'll plug 2 inside here, or I can actually solve it just to see. But I don't want it to think there, you know. It's a hence. So the hence here, it means use the graph from up here. Use what you have drawn up here to solve it. Not solve it straight, because it said hence. If it said hence or otherwise, then you could have solved it straight. but they really wanted to get from the graph, and that's why I made these markings and put those same markings on the graph to indicate on the graph how I got my answer. All right, but you can actually test these values, as I said, by either solving it or plugging these values in there. Let's just solve it. So if you had x squared minus 6x plus 8 equals x minus 2, you want to leave 0 on this side. So I'm going to take these and transpose them over here. So I transpose this over here first. I'm going to get minus 7x. So it's going to be x squared minus 7x. And then if I check this 2 and bring it over here, I'm going to add it to that. And I'm going to get 10. I'm going to get plus 10 equals 0. And if I factorize this, I'll get x and x. Factors of 10 and add to 7 is 2 and 5. Signs are the same. They are both negative. So you see, this factor will give me x equals 2, and this factor will give me x equals 5. So you see, I got the same two answers, 2 and 5. So this down here is just like a test. It's just a test. It's not what they want. This is just to test answers, to check, just to check your answers. Now, presenting this as a part of my solution. That's just my little check to see the answer that I wrote from the graph correct. Because if you solve it the normal way, you get the same answer. The calculation and the graph must always be consistent. They must match. All right, so it proves that these two answers that I got from the graph is correct. And then you have confidence in that the graph that you draw, in this line in particular, is a correct line. What to go to that?
Yes, sir.
Okay. All right. Remember, if you didn't get it, go and do it over by yourself. Go and work it over again. All right, number 10, which is a circle of measures. Chances are we did this question already, but no problem. More maths equals better maths. All right, this question says, the angle below, drawn to scale, shows a circle center O. This is the center of the circle. Therefore, means that this is a diameter, guys. That's a diameter. All right. It says vertices H, J, K, and L are of a quadrilateral line of circumference. So it means that this quadrilateral is cyclic. So the opposite angles in this add to 180 degrees. They are supplementary. It says PKM is a tangent. Once you have a tangent, you're looking for tangent and radius, tangent and chord. So tangent and radius make 90 degrees. All right. And for example, now, tangent and chord inside here is equal to the angle subtended by the chord up here at the circumference. So these two angles equal. These two angles equal. Tangent and chord, looking up for those things. All right. The chord is also subtending this angle up here. So this angle is the same as that as well. All right, but let's continue. Then they give you the measure of angle J, HJL in here. It's 20 degrees. That's on the diagram. And this one is 50 degrees. Now, note, always remember that a triangle formed from the center with the two radii is isosceles because these two blue lines are equal in length. Each of them is a radius. And so this triangle is an isosceles triangle. And so the angle opposite this side, which is 50, is equal to the angle opposite this side. It means then that this angle down here is also 50. This angle here is also 50 right away. Right, this is 50. And because this, as I said, is an isosceles triangle. All right, chances are they might ask us for this angle. Let's see. So that is that. It says, calculate given reads for each step in the answer the angle of the measure of angle HKL. Where is that? HKL. H to K to L. All right, that's this angle that I want. Let's read it out. So they're asking us to find this angle. Now, if you can't see what it is right away, what you always say is go back along the sides, forming the angular circumference until you reach a circumference where the angle is subtended from. Subtended from this point, these 2 points. They're subtended by this arc, or you could say they're subtended by this chord that I'm drawing in purple. What is the chord doing? The same chord is subtending an angle up here at the circumference of 20 degrees. So those 2 angles, this one up here and this one up here, are subtended by this purple chord or by this purple arc. Both of them are subtended by the same chord or by the same arc in the same segment. So they are equal. So this angle over here is 20 degrees, just like that. Because angles in the same segment are equal. So this angle is simply equal to 20 degrees. Right? It's equal to the 20 degrees over there. But angles in the same segment are equal, right? Angles in the same segment are equal. And that's when they're subtended by the same arc or by the same chord. If you want to write that as well, fine. But I think if you write this, that will be sufficient. They give you the marks for just writing that. Because those 2 angles are subtended by the same chord or by the same arc. So the angle is 20 degrees. And remember, as you find the angle, you put on the diagram. So it will help you to find other angles. So this angle right here is 20 degrees. Right, it's 50 degrees better. All right, that's 20 degrees. Next question says JOK, that's the angle at the center. All right, so that's this angle right here at the center. What's inside this triangle? Well, these 2 angles are up to 100, so this one must be 80. That total angle triangle is 180, so this angle here must be 80 degrees. That's if we're working this isosceles triangle. All right, so show the calculation. Remember, they gave us this, and I put this one as 50 as well. So this one is 180 minus the sum of these 2. All right, and it's an isosceles triangle. So this angle that I want now is equal to 180 degrees, total angle in the triangle, minus the 2 50-degree angles, which makes it 80 degrees. That's because the total angle in isosceles, that's why we have 2 equal angles. So the total angle in the isosceles triangle is 180 degrees. So the total is this 180, and the isosceles is given reason to why we have the 2 times. All right, so that is that. Next part says angle JHK. JHK. So JHK. Oh, I need to put on I have it already. So JHK. That's this angle right here. Let's look at it. All right, so we're trying to find now this angle up here, this one. So that angle is going to be 40. That's how we know it's 40. Because 2 is you can know it is 40. You can say, okay, this angle is going to be 40. How I know that angle is 40? Because the angle between this tangent and this radius is 90. This part of it is 50. So right here, so it's 40. So this chord will subtend the same 40 degrees at the circumference. That's one way. Another way, another reason why it is 40 is that the angle up here that we want, if you trace it back to reach the circumference, to find what is subtending the angle from all the way back to reach the circumference. So this angle up here is subtended from these 2 points. And there's a chord there. That chord is subtending 80 degrees at the center. For the same chord, we subtend half as much at the circumference. As angle at center is twice angle at circumference. So this angle up here, it's 40 degrees, half of the 80. All right, so basically that is that. I'm going to tell them angle at center is twice angle at circumference. That's why that one is 40. It's half of the center angle. So this angle up here that I want is equal to half of the 80 degrees, which is the one at the center, that's 40 degrees. But the one at the center must be twice one at the circumference. So angle at center, angle at center is twice angle at circumference. Circumference. All right, hold on a sec, guys. Hold on a second. That is the reason. Hold on a sec, please. Hold on a second. All right, guys, sorry about that. Okay, so that is that. Next part now says, all right, so finish. I finished that question. No, come to part B. It's a different question. All right, good. Part B is a different question. So part B is a bearings. All right. This question says a ship traveled from A. I don't care about the name A, from A on a bearing of 0-30 degrees to B. So from A to B, we're going 30 degrees, 0-30 degrees. So from here to here. Remember, the bearing is measured at the front position. So it's from A. The bearing is 30 degrees to B. Let's put that on the diagram. And it also goes 90 kilometers. Let's put that on the diagram right away. Let's put on the diagram. So at the front position, this is the north direction. They have it there for us. As the angle choose of a turn to the right, you go in the direction towards B up there. So this angle is the bearing angle. All right, so I'm going to put the 30 degrees on that. So this is 0-30 degrees. Then the distance is 90 kilometers. I put down the distance in a different color. 90 kilometers is that distance. And this is our north direction still. That's what we have so far. Then it says, it then traveled to C, contain C, which is 210 meters due east. Now, remember, due east simply means towards the east. And it's from A. So C is 210 kilometers from A now. So that's here from A to C. You're going east. Now, east is on a bearing of 0-90 degrees. So it means then that this is the east-west line right here. And it's 90 degrees to a north-south line. So the angle here is 90 degrees. All right. And the distance is 210 kilometers. So I'm going to put the 210 kilometers on this line. And since this is 90-degree bearing, 0-90 degree bearing, then it means that the angle inside the triangle here is 60. Now this is 30, and all of this is 90. Then inside the triangle here is 60 degrees. That's not a bearing angle, you know, that's just the angle between those two sides. So nice. We can come and work in this triangle and use cosine rule because we have two sides and an angle between them. So we can use cosine rule to find the side across here. All right, if they want that, which I'm sure they will. All right, it says, indicate on the diagram the bearing of 0 to 30 degrees, which I have here, the distance of 90 and 310, there and there. So I have everything on the diagram. Then it says, calculate to the nearest kilometer, meaning that don't put any decimal, to the nearest whole number, the distance between B and C. That's this distance. That's cosine rule you have to use in this triangle. Remember, can use so-called tower or Pythagoras theorem in a triangle that is not a right angle triangle. One is cosine rule. All right, so cosine rule. So remember, cosine rule starts out like Pythagoras, as it is an hypotenuse. Starts out like Pythagoras theorem. So like BC squared would be equal to this side squared plus that side squared. If it was Pythagoras theorem, 90 squared plus 310 squared. But it's not Pythagoras theorem, so if you subtract a piece, what you subtract? Twice the product of these two sides. Twice the 90 times the 310 times the cosine of the angle between them, which is the 60 degrees here. And instead of putting the square on this, we could take off the square and square root this instead and do one calculation, which is what I'm going to do. All right, so let me take this off. How can I leave the fact that we crossed it out and square root that? But that is it. And so the BC is going to be equal to whatever this is. And we can put all of that in the calculator one time. So we divide the screen now and do with that. So you reduce the amount of work that you have to do. Just put everything in the calculator. Use the full capacity, the full capabilities of your calculator. And let's I'm working this out. So look from the square root of 90 squared plus 310 squared minus 2 times 90 times 310 times the cos of 60 degrees, cos of 60 degrees of half. So getting 276.2, but it's at the nearest kilometer. So I'm going to write 276 kilometer. When I say to the nearest kilometer, I mean that they don't put any decimal on it. You go to the nearest whole number, 276. So it means then that this distance is equal to 276 kilometers. All right, that is that. Let's continue. Next part says, let's calculate the measure of angle ABC. So let's call it angle alpha on the diagram, angle ABC. ABC is the angle in here. And because we have this angle and side opposite each other, we know two of them, we can use sine rule by pairing up those angle and side opposite each other. All right, sine rule. So let's go. I'm going to write it right here, sine rule. So it's going to be sine of this angle over this side, sine of alpha over 310 equals sine of the angle that you know, which is the 60 over the side opposite to it. Over the 276. And you're transposing this now to make alpha the subject. Find alpha. All right, so let's copy this down. I'll cut it. Put it down here. Tell the examiner we're using sine rule. Find an alpha. All right, so to make this a subject now, you want to multiply with 310 first and put in front of the 3. So you're going to have sine alpha equals 310 and the sine of 60 degrees over 276. Then the alpha equals sine to the minus 1 of that. So the alpha is sine to the minus 1 of all of that. 310 sine of 60 degrees over 276. And then the alpha, which is that angle equal whatever this works out. Let's do it on the calculator. So it's sine to the -1 per fraction. It's 310 times 310 times sine of 60 over 276. And it is 76.6 degrees. I say themselves to the nearest degree again. I'm going to put 77 degrees. To the nearest degree, you don't put any decimal. 77 degrees. Just don't like it right. Well, let me write it good. That is it. Alpha is 77 degrees. Angle ABC. Let's put on the diagram 77 degrees. So this angle right here is 77 degrees. This one. What does they want now? They now want us to tell them the bearing of C from B. Always note the from position. So you want from B to C, the bearing. Draw this on the diagram and see how you're going to work it out. From B to C. So the bearing is measured at B. So you're going to come on the diagram. So you're going from here down to D. What is the bearing? That bearing angle, this is the north line. There's a clockwise angle to the line that is taking you down to C. So you want the bearing of this direction. This is the angle that you want. All right, so no matter how we're going to calculate that angle. Now, you can calculate that angle more than one way. All right, because these two angles now, these two angles, this one and this one, are co-interior angles. They add up to 180 degrees. So since down here is 30, and up here is 150. Up here is 150. And then now, this angle that you really want becomes 360 minus the 150 and also minus the 77. Because total angle around this point B is 360. All right, so we can basically do that calculation. I'm going to show you another way to do it. 360 minus 150 and minus 77. That gives us 133. So that's 133 degrees, right? That's the way I think most people would do it. But I want to just show you another way to do it. Look at this other way now. So it's 133 using total angle around the point. Let's look at another way. 133 degrees. Now watch this now. Another way to do it is just okay. We're really trying to find this angle here. All right. Now we know the direction of this line. So if I take that line, I'm draw it in purple. Take this direction line, A to B, and I extend it further out. The direction given as a bearing is 30 degrees, 30 degrees. So it means that this angle right here is the same angle down here, 30 degrees, because after the direction of this line, A to B, that's still the direction. Right? That direction is still on a bearing of 30 degrees. So this angle is 30 degrees. Remember, you know, this is now just part of this red angle that you want. So the other part of this red angle that you want is this piece inside here. I'm going to mark in green, this piece. So this red angle that they want becomes the sum of the 30 and this angle. The question now, what is this angle? Well, this now angle is part of the angle of this straight line. The part down here is 77. Total angle of straight line is 180. So this part of that angle that you want becomes 180 degrees. minus 77 degrees, which works out to about 180 minus 77, which is 103. Because total on this purple line is 180, and inside the part of it is 77. So the green part here becomes 180 minus 77. But the bearing angle is this red angle. This red angle is the bearing angle that you want, theta. So that theta becomes the 30-degree part here, so plus the 103 part here, so which gives you about the 133 just the same. All right, so the theta on this diagram becomes 030 degrees plus 103 degrees, which is 133 anyway. That is it. So 2 ways we can look at it. All right, let me put that 150 around here. I show the two methods in the calculation. So this angle down here is 180 degrees minus 30 degrees. These two add up to 180. They are co-interior angles. That is 150. So the first method was to find this red angle by saying total angle around the point is 360. It became 360 minus this and minus that. And the other way was to break it and recognize this direction is still 30 degrees. All right. So anyway, I think the first method would be the more popular method to use. All right, the more popular method. Let me write both of them. The first method was to say the angle that they want, theta, is 360 minus the 150 over there and minus the 77. That gives us 133 degrees. Or we could say the theta equals 0.33, 0.30 degrees plus 0.30 degrees plus the angle that we got here, which was 180 minus 77. All right, plus the 180 minus the 77. All right, so you get 133 again. Anyway, take it, that is the bearing angle there. But okay with that?
Yes, sir.
All right, let's continue under the last question. Give me a second, give me 1 second. 1 second, 1 second, 1 second. All right, last question now. Matrices, transformation, and so on, and vectors. This one gives us this matrix T, and it maps this point onto this point like a transformation, and I want us to get the value of C and D. So what is that this matrix times this point is equal to this point. So basically it sets up like this. Where are we going? It sets up like this. The matrix, which is C0, 0D, times the vector for this point, 2, 3, is equal to the vector for this point, 2, negative 3. We can do two calculations here to obtain the C and the D. Do it in red. It means that this row and this column is equal to the 2. So set that up. So it is C times the 2, which is 2C, and the 0 times the 3, which is 0, that is equal to this 2 over here. And so you really have 2C equals 2, which means that the C is equal to 1. And then now, this row times this column is equal to the negative 3. So we're going to set it up again. It is a 0 times the 2, which is 0. The d times the 3, which is 3d, is equal to this negative 3. So you're solving 3d equal negative 3. Divided by 3, the d equal negative 1. So basically, that's a matrix. Those are the answers. The C and the D that I want. This matrix T, let's write it here, is therefore C is 1, 0, 0, and the D is negative 1. And you should recognize this matrix on site. It is the x-axis reflection matrix. So right away, you know what you're dealing with. You're dealing with a reflection in x-axis. And this one also determine the image of this point on the transformation T. It's not complicated. You just need to look at the values change from this to this and change them the same way. So what happens? The x value stays the same, right? So minus 5, 4. Let's write it down in blue. No calculation needed for this one. It's mapped by T onto. So the x value stays the same. It's same it stays the same here. Stays the same down here as well. Changes in the same way. So minus 5 stays minus 5. Then this value stays the same value, but stays the same position, but change the sign. So all we need to do is take this 4, keep the same position, but change the sign. So become negative 4. This is the answer. Anyway, the matrix changes these values, it changes these values in the exact same way. Right? Determine the image on the transformation T. That is, so this is the answer right here. Very good at that?
Yes, sir.
All right, next one says describe transformation T fully. That's it. Reflection in x-axis should know it on site. A reflection in the x-axis. That's the x-axis reflection matrix. That's it. That's why you describe a reflection by telling the reflection, the line, reflection line. What line is the reflection? Reflection medium. Just see what the reflection medium is. Reflection in the x-axis, and that's it. You're done. Or the x-axis is the line y equals 0 if you want to see that. All right, that is it. Next one says find the matrix which maps Q back to P. A reflection in a line. The inverse of a reflection is to reflect in the same line. Because look, if you have a line here, you have P up here, and you reflect P down to Q here in the x-axis. This is Q. And you want to go from Q back up to P. All you have to do is reflect in the same line. So the matrix is the same reflection matrix because the inverse of a reflection is the same reflection. So this don't need no calculation either. Right? If you have that advanced knowledge, that reflection of the inverse of a reflection, the same reflection. So the same matrix T to the minus 1, inverse of T will be equal to T. If you actually calculate the inverse of this matrix T, you're going to get it back, the same values. All right? So the matrix that will map Q back to P is the inverse of T, was going to be equal to T, which is the same matrix, which is something that you should know. 1, 0, 0 minus 1, and it makes sense. That's because the inverse of a reflection is the same reflection. The inverse of a reflection is the same reflection. That's why the inverse matrix is the same matrix. But I get that? Some person will go ahead and calculate the inverse of T. You know, I want to realize that it comes back to the same matrix. So if you want to try it, you can go ahead. Once any of the reflection line matrices you take the inverse of, you're going to get back the same reflection gonna get back the same matrix. But the inverse of a reflection in a line is to reflect in the same line. All right, let's continue. Part B now, so the last question is a vectors. All right, a vector. It says, graph below shows 3 points, P, Q, and R, relative to an origin O. So P, Q, and R. This is origin O right here. All right, let's see. It says, write down in column vector form OP. Now, P is the point right here, 4, -1. So OP is going to have the same values in column vector form. So that's 4, -1. You can also Q one thing at the same time now. Q is 0, 2. 0, 2. And the R is 3, 7. R is 3, 7. You know what's the vector? QR. QR is OR minus OQ. OQ. O times the last minus O times first. We can do it by calculation, but we can do it from a graph as well. So let's do it by calculation first. O times the last minus O times first. So the OR is from this vector. It is 3, 7 minus OQ. So this vector 0, 2. So that says 3 minus 0, it is 3. And 7 minus 2 is 5. 3, 5. So we could also get it from the diagram. How do we go from Q to R in the diagram? Look. We go from Q to R on this diagram. Let's use it red. Going this way, 3 units. And then going up here 5 units. And count it off. 1, 2, 3, 4, 5 units. 5 up. That's why QR is 3, 5. 3, 5. Hold on a second. All right. So that's this 3, 5. 3, 5. So we can get it from the diagram as well. Okay. So anyway, take it with this 3, 5 by calculation or from the graph. Next part, what's the magnitude of QR, which is the length of the line. Use the formula method where the modulus of QR, magnitude, length, and modulus is the same. Become the square root of this value squared plus this value squared. That's 3 squared plus 5 squared. That's 25 plus 9. That's 34 units. That is it. I don't have to write this out fully. Again, if you look at the graph up here, it is like you have this is 3 units, and up here is 5 units. I'm trying to find the length of this line QR, this length. So you're working the right hand trying to use Pythagoras' theorem, that becomes the hypotenuse. So this length will be the square root of 3 squared plus 5 squared. So the same thing, right? Magnitude is length of the vector. Modulus, same thing. All right, so making the connection. Then down here now, it says on the graph, provided we have to draw the vector OS, which is 7, 4. Now, if OS is 7, 4, it means that S is a point with the same values, 7, 4. I want to put 7, 4 on the graph and then draw the vector from O to the point S as the vector. 7, 4. So 7, 4. So 7, 4 up to here, this point. That's 7, 4. That's the point S. And I want us to draw the vector OS. I'm going to draw a straight line out here like this. That is the vector that I wanted, OS. This point is 7, 4. But then now, the other part says we have to show we have a parallelogram, right? And so we draw the vector OS. It says show that PQRS is a parallelogram. Now PQR is a parallelogram. It means that the opposite sides are equal in length and parallel. So it means then that the opposite sides are equal vectors. And that's why you show that it's a parallelogram. It's a parallelogram, then the opposite sides are equal vectors. Let's look at it. Let's look at it. So we have PQRS. I'm going to complete it. So we have that. That is the PS line. That is this line. So the opposite side will be equal vector. What vector do we have already? What vector did we calculate already? I don't want to recalculate anything. So we have QR already. QR. So we already have this vector over here. So it must be equal to PS. That's the first thing. PS will be equal to whatever QR is. That's the first thing you have to show. So that's all we need to show for it to be a parallelogram. These two sides are equal vectors. Then the other side now would be these two. I will do a PQ, I will do a SR. So we can go PQ and SR. So we can also show that PQ, SR is equal to PQ. We need to show these two things to show that we have a parallelogram. All right, we can do calculation or we can use a diagram, but let's do it by calculation. So this is what we need to show that we have a parallelogram. You know, tell the examiner that's what you need to show. Once you show it, you're good. All right, so let's go. Paste. That's what we need to show. Let's copy down some of the vectors that we already know. So we need to show this, right? And we have OS. Let me write down the vectors that we know. So we have these three. We have this one already. We have QR already, it's 3, 5. So we can write that down. QR is already 3, 5. QR on this line, QR is 3, 5. So we need to calculate PS and shows that it's equal to Q5. What else do we know? We do another vector about all these points. We'll copy these points down. We can use them. All right, let's do step by step now. So we're doing this one first. This one. We have the QR vector already, so we really don't need to calculate PS. All right, so PS, let's do it in purple. Let's do it right here. PS is going to be OS minus OP. The OS is this 7, 4 minus OP. OP is going to have these values 4, negative 1, which is going to be 7 minus 4 is 3, and then 4 minus a negative 1 becomes 4 plus 1 is 5. That is PS. But 3, 5 is also QR. So it means that PS is equal to QR. So they show this part already. We need to show this part now. So we need the SR and the PQ. So when I say no, the SR, how do I have it now? Is OR minus OS. Out on the last minus out on the first, which becomes the OR is 3, 7 minus the OS is this 7, 4. And this works out. This is SR. So SR is really 7 minus 4. 3 minus 7 is negative 4. And 7 minus 4 is 3. It's a record this part now, PQ. Beside it. So PQ is OQ minus OP. O time the last minus O time the first. The OQ is this one, 0, 2. Minus OP is this one, 4, -1. And these will equal to -4. As minus becomes a plus, it becomes 2 plus 1 is 3. And so we have a second thing. Right? Look at it. It's what them equal. The SR is equal to the PQ. SR is equal to PQ. And therefore shown. Can you show this? Show this. This is true. Right? Therefore shown. I tell him that's what I'm going to show him. And then I show it. I show the PS equal QR. And I show the SR equals PQ. So I show these two things. Right? To show that this is a parallelogram, I need to show these. To show that this is a parallelogram, I need to show those two things. This. That's why I presented it. To show that this is a parallelogram, I needed to show these two things. And the opposite sides are equal vectors. And I did that. And so we are done. End of this test. And that is that. Is that. But good?
Yes, sir.
What's up? What's up over here? Hope other people will watch the video. We did do the class, and that's what I'm going to be from now on. Plan is to have the class at 9 a.m. And I started them on the revision class because the actual exam is going to be 9 a.m. And we'll start doing mock exams on Saturday. They're going to be at 9 a.m. So I'll get people used to that now. All right. So that is it for today, guys. See you all in class Sunday and Monday. Bye, everybody. Bye-bye. I'm going to share the video. Share the recording. Bye-bye.